Differentiation Part 4. In the previous video, we have already discussed that how to make good use of the product rule to find the derivative. This video, I would like to introduce two more theorems. The first one is called quotient rule. If you want to know the proof, maybe you can go for it. But I want to make good use of the example to illustrate how can we make good use of the quotient rule to find the derivative. Let's see the following example. Example 4.8. Part A. Y is equal to 2x squared minus x over 3x plus 1. We can regard this function include two parts. The first part is the numerator, which is a polynomial, and the denominator is also a polynomial. Include the division, so we will call this is quotient rule. What is quotient rule? If we want to find y dash, we can take square of the denominator, x plus 1 all square, and then put down the denominator first and find the derivative of the numerator. Remember, this is minus sign and put down the numerator and find the derivative of the denominator. So simplify the numerator. Keep the denominator, and then according to the previous theorem, the power rule and the additional law of the derivative, this is equal to 4x minus 1 and minus 2x squared minus x, and then this is 3. We may simplify it. 12x squared minus 3 plus 4x is plus x minus 1 and minus 6x squared. Remember, this negative sign, we need to distribute it. So this is plus 3x over 3x plus 1 all squared. And this is 6x squared plus 4x minus 1 over 3x squared plus 1 all squared. Because we cannot factorize this term, so that this is your final answer. We can also make good use of the quotient rule to do part B. Let's see. Y dash. Take square of the denominator and put down the denominator first. And d over dx, this is 1, so must be equal to 0 minus. And then 1 time, find the derivative of the denominator. This is 4x minus 3. So the first part is 0 because d over dx, 1 is equal to 0. The derivative of a constant is equal to 0 and minus 4. So the answer is negative 4 over 4x minus 3 all square. Okay, turn to page 7. You may pause the video and do the follow-up exercise 7 first, and then check your answer. I will demonstrate how to use quotient rule for this 3 example, but please do it by yourself first. According to the quotient rule, we can take square of the denominator first and then put the denominator on the denominator and find the derivative of the numerator. And then minus, put down the numerator and then find the the derivative of the denominator. So simplify it. The first part is equal to 2 and the derivative of the second part is equal to 1. And then simplify it. This is 2x plus 6 minus 2x plus 1. So the final answer is 7 over x plus 3 squared. Part B. According to the quotient rule, the derivative like this, and then d over dx of a function which is equal to 4 is equal to 0. So the first part is equal to 0, subtract 4, and derivative of this term is equal to 2x, so it's negative 8x on your numerator and the denominator is equal to x squared plus 2 all squared. Part C, according to the quotient rule, maybe this function is very complicated. This is x squared minus 3x plus 1 all squared. And put down the denominator and find the derivative of the numerator is equal to 2. And then minus, put down the numerator and find the derivative of this term. This is equal to 2x minus 3. And then simplify it. This is 2x squared minus 6x plus 2. And remember, this negative, you need to distribute into the function, to the polynomial. So remember, be careful on the negative sign. So this is 4x squared plus 12x minus 9. So simplify it. This is the final answer. The last theorem I want to discuss with you, which is called train rule. What is the meaning of a train rule? I want to demonstrate by using the example 4.10 to demonstrate what is train rule. Let's see this example. If I want to find the derivative of these functions, what can we do? Remember, we cannot use the power rule. We cannot write down the power and degree minus 1, because if you want to use the power rule, this term must be same. This is x and this is also x. So maybe you need to use binomial expansions to expand it, because you know how to expand the polynomial with degree 7. But very complicated and a lot of terms. So what can we do? What is chain rule? I want to, if this one is equal to this one, is the best, because we can make good use of this power rule. Then, according to the train rule, we can change the derivative like this. Now, they are equal, but this term is not exactly equal to this term. What can we do? We can time now they are equal now, because maybe you can regret this one is a function, fractions, because I want to make them equal, so I need to add this term. According to the cancellations, they must be equal, okay? Because after the cancellation, this is 1, and 1 times dx is equal to the original one, and then this is 1, so they must be equal. Now, we can apply chain rule, because this part is equal to this one, just like this one. Dx to the power n over dx, but this one, the x is the whole term. So write down the degree, and then degree minus 1 is 6. And you know how to find the derivative of this term. It's a simple polynomial, so it's equal to 9x squared plus 12x. Okay, remember we need to add bracket. Maybe you can take out 3. This is 21 times 3x squared plus 4x. And then this is 3x to the power 3 plus 6x squared minus 2 to the power 6. Yeah, this is the final answer. You do not need to expand it and simplify it. Okay. Let's see one more example. How can we make good use of chain rule? I want to change the function like this. 1 over 2 x plus 3 to the power negative 4. Because I don't want to use quotient rule. Okay, I want to use chain rule directly. So this is 1 over 2. I need to take it out, because I know if I want to find the derivative of this term, I can ignore it. Okay, find the derivative of the this part and time 1 over 2. So what is y dash? Y dash is equal to 1 over 2. Okay, write down is step by step according to the chain rule. I want to apply the power rule. So I want to find the derivative, okay? It's similar to. Remember, you need to present your work better. For example, when you are simplifying y, the function y, so this is y. And after taking the derivative, okay, this y become y dash. And then 1 over 2, according to the power rule, -4, and degree minus 1 is minus 5, and this one is equal to 1. So this is the final answer, -2x plus 3 to the power -5. This is a very powerful theorem and very useful. Turn to page 19. For example 9. Pause the video and try to do it. Let's check the answer together. Part A. According to the train rule, I can change the derivative like this. D, the original function over, because I want to use the power rule, so they must be equal, and time D, 2x squared minus 7x plus 3, because I need to make them equal, so over dx. This part, I can make good use of power rule, degree minus, write down the degree and degree minus 1, and the derivative of this term is equal to 4x minus 7. So, rearrange the order. This is your final answer. Part B. Part B. According to the train rule, this two I can take it out first. Okay, just consider this function, and then according to the train rule, you can make good use of power rule, 3 times the original function and degree minus 1, and the derivative of this term is equal to 3x squared minus 12x. And then because I find one common factor of this term is 3x, so I take it out, remain, this one is x minus 4. Okay, so the final answer is 12x times x minus 4 and x to the power 3 minus 6x squared plus 1 squared. Okay, part C and part D, you may do it, and then let's discuss during our lesson.